Okay, today's lesson talks about section 5.9, which deals with transforming linear functions. The learning target is I can describe how changing slope and y-intercept affect the graph of a linear function. For starters, we have a couple definitions. A family of functions is simply a set of functions whose graphs has the same basic characteristics in common, and the parent function is the most basic function in a family. And then a transformation is simply a change in position or size of a figure. And we're going to be looking at three different types of transformations today. For starters, I'm switching slides here. Mrs. Gibson, Mrs. Lagana students will have different slides, but I think this will be very helpful. The three transformations we'll be looking at today are 1, a translation, which is simply a slide, 2, a rotation, which is a turn about a point, and then 3, a reflection, which is a flip over a line. So continuing with that, what we're going to do is I'm actually not going to do the examples on the notes that you were given. I'm going to use my own and then go back and revisit these here in a little bit. So using my notes, we're going to go ahead and take a look at translations first. And we're going to start with graphing the function f of x equals 2x plus 3. To graph that, we'd go ahead and start with our y-intercept, which is 3. And we'd go ahead and go up 2 and over 1, up 2 and over 1, and continue with that pattern. And I'd then go ahead and fill in the graph by completing the line, and it would look something like this. And I'm going to go ahead and label that as f of x. And then what we're going to do is we're going to go ahead and graph g of x, and I'm going to do that in blue. We'll start down here with our y-intercept of -6, and again we'd go up 2 and over 1, up 2 and over 1, continuing to fill in the graph. I'll go ahead and graph that line now. And if you take a look at what we have after I label it here, you'll notice we have the exact same line, except it was simply shifted down to a new y-intercept. Okay? So we're not changing the line, we're simply shifting it or translating it down or sliding it down, I guess you could say. All right? If we were to describe what happened there, going from f of x to g of x, we would say it translated down 6 units. So, I'm sorry, I was saying 6 units is actually 9 units. My mistake. We're going from +3 down to -6. So let me make that change. So again, we're looking at the y-intercept originally of +3, going down to a y-intercept of -6. So that's a difference of 9 units. Now I'm going to go ahead and graph the next function, the h of x, and it's kind of like saying 2x plus 0, meaning the y-intercept is here at 0, but we're going to go up 2 and over 1 and up 2 and over 1 and fill in that graph. Once I've graphed it and labeled it, squeeze that in here. There's my h of x. I'm now going to describe this transformation going from f of x to h of x. So notice how I'm starting with the original function. And if you notice, we simply translated it down 1, 2, 3 units. So that's the transformation that I'm going to describe. We're going to say that it was a translation down 3 units. And that's what translations are all about. Okay. Moving on now, we're going to take a look at rotations. And for the rotations, again, we're going to go ahead and graph these. I'm going to start off by doing my 2x minus 1. And once again, I'll go ahead and label that as my original f of x. I'm going to graph my g of x. Now this one has the same y-intercept, but we're going to be going up 1, 2, 3, 4, 5 and over 1. 1, 2, 3, 4, 5 and over 1. And I'll go ahead and label that now, or fill that in. And it's going to look something like this. So there's my g of x, and what happened is we have the same y-intercept, but the graph went this direction. It kind of spun backwards in a counterclockwise direction. So that's how we're going to describe this transformation. Going from f of x to g of x, it was a rotation, and would say it's counterclockwise. Your teacher may or may not require that part of the written explanation, but it's a rotation counterclockwise about the point 0, -1, because that's where our y-intercept is. Down here at 0, -1. We also need to indicate whether it became steeper or less steep, and in this case it became steeper. Now, I'm going to go ahead and graph the final function here, this h of x. Once again, it has the same y-intercept of -1. We're going to be going down 3 and over 1, down 3 and over 1. So this one actually has a negative slope. There's my graph. And once again, I'm going to go ahead and label that as my h of x. And in comparison to the original function f of x, it started here, and once again it rotated counterclockwise. It was about the point 0, -1. Now, as far as the steepness of it, okay, if you compare the original steepness of f of x, which had a slope of 2, and the steepness of h of x, which had a slope of -3, remember the slope is the rate of change. We don't care whether it's a positive or a negative rate of change, but this -3 right here has a greater absolute value than the positive 2. So this one actually became less steep. So we are going to say it's a rotation counterclockwise. And once again, it is about the point 0, -1. And in this case, it did become steeper once again because it went from an absolute value of positive 2 to an absolute value of positive 3. Now, the final transformation we're going to look at here, going back to looking at the steepness, if you compare the steepness or rate of change for f of x here, the absolute value is 5/2, or really 2.5, or 2.5. The absolute value of this slope, or rate of change, is 4. And the absolute value of this one is 2. So this number right here would indicate that this would be the steepest line of the 3. So again, we're looking at the absolute value of the slopes. Now, continuing with the last transformation, this one is called a reflection. And I'm going to go ahead and graph the f of x as I've been doing. Up 1, 2, 3 over 1. There's my f of x. And now I'm going to be taking a look at what happens when I go from f of x to g of x. So again, we have the same y-intercept. We're going to be going down 3 and over 1, down 3 and over 1. So this one has a negative slope to it. And that's what it would look like. There's my g of x. Now, as far as this goes, if you take a look, if you picture an imaginary line splitting these two in half, which is essentially the y-axis here, notice how, right here we have it looks like 1 unit away. There's a point 1 unit away there. 2 units away, 2 units away here. 3 units away, 3 units away. So what we've created is actually the mirror image, okay? Now, although this is a rotation, to be a little bit more accurate, we would actually call it a reflection about or over the y-axis. So that's how we would describe a reflection. Now, what I've done here is I've gone back to Mrs. Gibson's and Mrs. Lagagne's examples, and I'm going to give you some time to complete the examples that she's given, or they've given. You can go ahead and do them right now, including the ones at the bottom with the graphing calculators if you have them. So why don't you hit pause, take a little bit of time to do those, and I'll reveal the answers when you come back. Okay, if you take a look now, I revealed the answers. Going from f of x to g of x, it looks like it was a translation up 3 units because the y-intercept changed from 0 to 3. And then going from f of x to to h of x, it was a translation down 6 units because we went from y-intercept of 0 to a y-intercept of -6, which is a difference of 6 units. And on the bottom here, using a graphic calculator, we went from a y-intercept of +4 to a y-intercept of -2. That's a difference of 6 units down. And there was a little typo on number 1 in case you didn't catch it. This should have been an equal sign. All right? So I'm now going to go ahead and give you a little bit of time to do the rotation examples. You can hit pause, but before you do, unfortunately the answers are sort of on here. Maybe ignore them and try them on your own. But go ahead and give them a shot right now. Okay, here are the solutions to the rotation being shown. I'm not going to read through them. You can take a look on your own. The graphs are labeled now. A little bit cluttered. I apologize for that, but you should be able to interpret it from there. I'm now going to go ahead and go to the reflection. Again, take a little bit of time. They're there for you, but try to do it on your own. I'll suggest you go ahead and hit pause, and I'll reveal the answers when you return. Okay, we're now going to take a look at a couple more examples here. The additional example, it says we have f of x equals negative 2x plus 6, and they're asking us to write a function to describe the reflection across the y-axis. Well, if you think about this, reflection, all that happens with that is we keep the same y-intercept, but the slope changes. Instead of being positive, it goes to negative, or vice versa. In this case, if it's negative to begin with, and we're trying to create the reflection, all we do is we go ahead and give the function a new name of g of x, and we change the slope from a negative 2 to a positive 2. And again, we do keep the y-intercept the same, so that would be a function that would describe the reflection across the y-axis. And then finally, the last example on this page asks us to graph f of x and g of x. But something interesting happens here. When I graph the g of x, let's see what happens. We have a y-intercept of 0, and we're going to go up 1 and over 1. So graphing that's going to look something like this. And when I go and label this, let's see, there's our original f of x. When I go to graph my g of x, I know that two things actually. The y-intercept has changed and the slope has changed. Okay? So I'm going to go ahead and graph this and then describe it afterwards. Here's my g of x. It now has a y-intercept of 1. And we're going up 3 and over 1 and up 3 and over 1. So I'll create that line. We'll label that as g of x. But as far as the description that occurred, going from f of x to g of x, there are two transformations. We first change the slope from a positive 1 to a positive 3. So what happens there, when we change slopes, that creates a rotation. And actually, let's go ahead and list whether it's clockwise or counterclockwise, and it's going from 1 to 3. So that's going to become a steeper one, which means it's going to be counterclockwise in this case. So it's a counterclockwise rotation, and it is about the original y-intercept of 0, 0. And it did become steeper, going from 1 to 3. But then, when we changed the y-intercept from 0 to 1, that also created a translation. And the translation occurred going up 1 unit. Going from that original y-intercept of 0 to the new y-intercept of positive 1. So this is what we call basically a double transformation, where we first change the slope, which causes a rotation, which affects the steepness, and then we go ahead and take that new line and we translate it up or down based on the change in the y-intercept. So finally, moving on to the last slide. If you take a look, the teacher's asking you to try with a partner using graphic calculators, or if you don't have the graphic calculator, you can do it the old-fashioned way on graph paper. But go ahead and try these 4 problems. Why don't you go ahead and hit pause? I'll give you some time to do it, and when you come back, we'll go ahead and reveal those answers to you. Okay, there you have it. There are the solutions to each of those 4 examples. And finally, one last thing, wrapping things up. What I suggest is maybe sitting down after you've seen these examples and to kind of organize your thoughts, go back and look at each of the 3 transformations we looked at today, and maybe make a little summary about as far as whether or not they occurred due to a change in the slope or a change in the y-intercept, or possibly both, and just kind of organize your thoughts that way. And keep in mind, sometimes there are double transformations that occur, and also keep in mind the things that need to be written down to describe those transformations. Okay? Good luck. I hope this video is helpful.